The following is my conversation with Mr. Wilson Chua, founder, entrepreneur, data scientist, and prominent tech columnist. I first ran into Wilson about a year ago when we discussed the topic of telco cybersecurity and fake news. Later, I collaborated with Wilson on dengue detection, and the work his team had done in the mosquito real-time census project in Facebook became the initial concept of what would later become Project ADES, which won for us the 2019 NASA International Space Apps Challenge. In this conversation, we will be talking about COVID-19 contact tracing, which is still a very relevant topic because as of this time, the pandemic continues to rage in many countries. Those countries that have successfully flattened the curve attribute their success to contact tracing and testing. At the same time, data science and analytics enthusiasts will enjoy our discussions on graph algorithms, network analysis, and Neo4j, which Wilson uses to great effect in this conversation. I really enjoyed my conversation with Wilson, and I hope you will too. If you like this chat, please like, subscribe, and share this on social media. So welcome, Wilson.
Yeah, hi, and thank you, Dom, for the introductions. Let's just jump right into the topic at hand. If I have my LinkedIn profile at the end, so if you like to collaborate, feel free to message me. So with the present COVID, as early as January, I wrote about it in my column for Tech News Manila that, the government could prepare in advance of this COVID by already talking to the two telcos for the mobility data. The idea being that the mobility data can help us track people who they came in contact with. No, nothing happened with that. So I partnered sometime in April. I partnered with the Philippine Society of Public Health Physicians to advance and promote the use of network graph analytics. So machine learning usually is with predictive analytics. Network graph is another animal altogether. But later in the presentation, I'll show you why it's important. So without further ado, I'm presenting to you the actual case of a client that engaged our group to help them flatten their COVID curve. So you will see the chart below. The x-axis is the dates of the start date of the infection of people. So, they're numbered 1, 2, 3, 4, 5. So there are days that you have 7 infections in the factory. Okay. So again, this is the chart. It shows how many were infected and on what dates. And you can see as the dates, as the days progressed, the number of cases steadily grew, and even the intervals are now closer and closer together. So this was at the time that they called us in. And within 14, the first 14, 24, 14 to like 2 to 3 weeks, the policies and the data already showed significant reduction in their peak. And then after another week, you can see that, they essentially are flattening the curve. Not only are they getting only one infection, but the timing between the infections are taking longer and longer. So this is the story of what happened. A background to this challenge was the data we used was from this company with around over 10,000 employees. And at the time, approximately 10% of their workforce was affected. Now, when I say affected, it doesn't mean 10% of their workforce had COVID, but 10% almost did not come into work.
So that was the impact of the epidemic on them, no?
It's the fear factor, right? So you don't need to have 100 people infected to affect 1,000 people not coming in. Just even 1 or 2 can get the social chismis network running, and the rest would be driven by fear. And the rest would say, it's not worth it to come into work and to get the disease. The cost of hospitalization is higher than what I can hope to earn, right? So that was one of the challenge. So you have to instill some sort of confidence in the workforce that the company was doing everything it can to make the workplace a safe place, right? Now, the thing that's going for this client is, unlike the rest of the Philippines, this client collects a lot of data. When an employee comes into the factory, they ride in shuttles. The shuttles have QR code for each seat. So we know where they sat. We know what ride they took. Now, when they go to lunch, which canteen they went to, which table, which seat number, that's also is documented by a QR code, right? And then there's this daily health declaration. The company also collects the data in digital form. Even up to the POS, the point of sale, they know who was who was in line before you and after you, right? So they have a lot of interesting data that we put to good use. And so the challenge here was to find strategies to help both contain the local transmission and to inspire confidence so that people will be willing to come back to work, because their perception is that, you know, their probability of getting it at the workplace is now super low. All right. Now, the data, we used Neo4j for this one. There are 16,586 nodes. This contains both people, place, and shuttle rides.
Right.
And
It's not all people, no? The
it's not all
16,000.
people, the 16,000. So in network graph analytics, an object, a node, can represent anything. It could be a place, a barangay, a city, a household, a person. But in this case, most of them refers to employees. Now, there are 11.7 million relationships that we're mapping here. So when one person ate at a canteen, that's one relationship. When two persons are close to each other, that's another relationship. So we're mapping almost 12 million relationships in the span of 45 days. So before we go further, let me give a very short theory behind the science. So this is from Johns Hopkins. Okay, this is the typical CDC scenario. A person, index case 0, gets infected on day 0, and typically their symptoms will start to show up on day 5. All right? Now, that person on day 5 will then get tested, and they will have their sample collected around 7 to the 8th day, and they will get, you know, in the US, same day or next day results returned. And by the 9th day, if they're positive, the government would have isolated them. So that's why you now have a pink area. So this is the area where the person still has viral load, but it is no longer infectious because they're being isolated, right? Now, our role in using data is to help our contact tracing teams identify, predict, or even identify infected people even before their symptoms start to show up. So this is what I call the holy grail of contact tracing and isolation. The closer to day 0, you can identify the person, meaning this person still asymptomatic. And yet we cannot then identify or predict that this person is going to get it. If we can identify and do this before their viral load starts to go up, we can have a better chance of beating COVID spread or killing.
It's like an early warning, no?
Correct.
Approach, no?
So,
Prophylactic approach.
yep. So we're killing the chain of transmission, right? Okay, so that's the background theory behind why contact tracing, when done early and when complete, you know, everybody as complete as possible, and you can identify all of them within the first 20 to 48 hours, that's the holy grail. That's what we need to do. So to illustrate, and because of data ethics, I cannot use the actual employee's name, so we'll use the fictional characters from Game of Thrones. Let us say that Tyrion Lannister has been tasked with the with the mission of coming up with a peace pact among the various warring factions. So, and let's say assume that Tyrion Lannister is infected with COVID. But 2 days before the symptoms show up, he already talked to Sansa Stark, Jon Snow, Arya Stark, Catelyn Stark, Jaime Lannister, Peter Baelish, Robb Stark, and Joffrey Baratheon. You know why I say 2 days before symptoms show up? Because according to the CDC, 2 days before you are symptomatic, you already have enough viral load to spread the infection.
To infect others, right?
To infect others. Now, let me see if I have a AI composed background sound. Can you hear that? Can you hear that? No.
Very soft.
Yeah. So this is from AI.
Yeah, we can hear it.
And so, okay. So that's the AI inspired thing. So it occurred to me that in such a scenario, this is a perfect example or perfect use case for Neo4j, or what we call a network graph. So like here, this person with the A label, that's Tyrion Lannister. And these are all the other persons he interacted with. So in a graph like this, Tyrion Lannister is somebody, person A is somebody that we call has a high degree centrality. So bear with me, I know you're very familiar with this. I'm just going through the basic just in case we have listeners that are not familiar with network graph theory. So
Yeah,
in
there's quite a
essence,
lot of network metrics, right? That you can do.
right, you're right. So again, as a basic, each circle here represents a person. And each interaction between a person and another person can be shown by a line, or what we call edges or links. Yan. So in this representation of the interaction of this person A with all these other person, we can say that he is a person that has a high degree centrality. So yeah. So what it also means is in a community, you don't want person A to be infected, because once he is infected, he has the potential to be the super spreader. All right? So A is a potential super spreader by nature of his high degree centrality. Now, next person is person C. Person C only has links to 2 people, but his betweenness score is very high. And you know why? Because infections from Tyrion Lannister's group can never cross to this other group here without passing through person C. So person C in the Philippine context might be what we call the LSIs, the locally stranded individuals. So like, if they were never infected when they go back to their barrios, they would never be able to spread COVID to their barangay, right? So this is that person.
So that person is the bridge, no? That
Exactly,
carries
that's a
infection,
right, very nice analogy. Tulay. So if that tulay is broken, the disease from one community cannot go to another community. Clear?
Yep.
Yeah. And this is just the closeness centrality, and page rank is this D guy. Now, this illustration is taken from the book Graph Algorithms by Mark Needham and I'm Amy Hadler. The reason I chose this is because for the next 15 days, this book is free. You can download
Wow.
it
So
for
it's
free.
free for
Ebook.
download. Yeah.
Yeah, ebook. And this is exactly the same book I studied to get myself certified. So if you go through this book, you can go through the Neo4j certification. All right.
Actually, if I can just dwell on this
All right,
diagram.
go. Sorry.
I remember when a couple of months ago,
Mm-hmm.
you know how a lot of these predictive models were coming out now on the epidemic, and one of the concepts that I think it it was very abstract for the public, is this notion of how well mixed is the population. Like, for example, if you want to predict the likely number of cases, you have to understand what is probably the denominator, no, or the susceptible population. And it's so, I guess, very easy to say, oh, it's 100 million because there are 100 million people in the country. But the way a graph or a network graph would show it is, it can't be 100 million because you're not connected to 100 million people.
People,
I
yes.
mean, we're spread out in islands in various cities. So unless you're flying all over the place, it's very difficult for a single carrier to infect 100 million people. But then understanding just how well mixed is the population. So, for example, within a Metro Manila, it's probably, if you live perhaps siguro in Makati City or some places which are close to main thoroughfares, no, like I remember San Juan was a big hotspot because of Green Hills, because everyone passes through Green Hills in some shape or form. But then there are some areas that are fairly isolated, no, so it's very hard to get infected. And then you mentioned super spreader. I think there was a recent case about a couple of months ago where in BGC, no, in Taguig, there was a construction worker who was identified as a super spreader, and it's because within let's say a construction site, all the workers are like mingling around and
Yeah. And he moved around a lot, and he intermingled with a lot of people. That's the person A.
yeah.
And
So
so,
so this graph is a great way to define that, no? To parang demystify this concept of how well mixed is a population, how does this disease spread, which I think not enough even in the public, no, but even within the data community, we don't see enough people actually playing around with graph analysis. I think this is really good.
right, because usually when we do machine learning, we work with variables, and none of the variables include the network metrics. And so it's like you don't have context into the society, into how a particular community or barangay, but once you know how people interact with each other inside a community, you can really look at how it spreads. And I will show you later in the later slides. I will share with your viewers some of the exciting things to me, but depends on the person. To other people it might be boring, but to me it's fairly exciting. So can we proceed?
Yes, of course, go ahead.
Okay, all right. So here are some of the use cases for network graph analytics. Because we had the data, the client supplied us with the data. Again, for the data ethics side of it, we never got the true names of the persons. We only had a tokenized ID. So there's no way we know who these people are, right? But we could use the network graph analytics to really quickly surface all of the close contact of a given employee that then became positive. And we can do this in under a minute. So like Mayor Benjamin Magalong of Baguio, who's our contact tracing czar, did say that, for every positive, you should target about 37 contacts. Guess what? Because we had enough data, we surfaced more than 37 on the average for each positive case, to the point that, maybe it's too much.
Yeah, but at least that's valuable information, no? As opposed
Yes.
to shooting in the dark and mass testing everyone, which is obviously a cost challenge. But then that's on the one extreme, no? And then on the current extreme, naman, where we're not testing enough. This process gives us a good middle ground where we won't test everyone, but we'll test likely suspects and hopefully isolate the patient zero, for a particular cluster.
Patient zero and those that he has already infected, but who hasn't shown any symptoms yet. So this is fairly advanced and fairly effective, if I may say so. So second, also, once we were able to identify the close contact, that's something simple. We wanted to see if we could do predictions. And predictions, turns out, are closely related to us being able to identify clusters within the community. And then once we had that data, it's also another thing to visualize them in a manner that it tells a story so that the chief executives that we're talking to can quickly grasp the concept of, how did this spread and which community did it spread to. Then we can use 1, 2, and 3 to help with number 4. The cost of a RT-PCR test is anywhere from 5 to 6,000. And so if you're a company with 10,000 people,
It's going to be a lot of money.
that's going to be a lot of money. So is there a strategy that we can recommend that can help them test the more probable cases, and at the same time help them have a better ROI, right? So we will share with your readers today. And number 5, we will show that network graph metrics can improve machine learning algorithms. And finally, number 6, we will show how network graph analytics also takes care of the sparse data. So by sparse data, well, anyway, I will explain when we get there.
I think number 5 and 6 will be of special interest to a lot
Yes.
of our viewers because, yeah, I mean, it's number one, not enough people actually deal with networks. Everyone's used to the usual mga regression models and
Like,
machine learning and
so age,
decision
sex,
trees.
locality,
Yeah.
ethnicity,
And
blood pressure,
it's a column and row relationship, and I think
Correct.
a graph relationship just adds so much more
Context.
dimensionality and context.
Yeah. So it's very easy, especially for Neo4j. You can see here, my command here is show me all the employees with ties to case number 81. This is case 81. And boom, in plain English, we are able to surface all of these pink. So all of these pink nodules are employees that are exposed to case 81 during the infectious period of
Right.
case 81.
So you have a time window, no?
Time window. So we're eliminating a lot of false positives. And you guess what? This system was able to catch 43% of the new cases. So ibig sabihin, among these pink that we predicted, that we identified as close contact, 43% of them later on turned out to be positive. So what happened here was, the company says, okay, all of you are exposed, isolate. And during isolation, 43%.
That's 43% less mistakes, if you think about it, right? Because it could have been 100% false positive. And now,
Correct.
you found a way to at least catch 1 out of 2 people are probably likely to have the infection. And then that's powerful if you think about the cost savings.
Not only the cost savings, but if you think about the R value of, let's say, 2, if you're able to eliminate 2 at the onset,
and that's it, no?
The savings compound.
Yeah. And then before you move forward, no, that statement on top, that's exactly the because I've used Neo4j a few times, but it seemed to me like it's similar to a query language, no. But
Yes.
You're saying that currently Neo4j can take basically an English question and then generate an analysis.
So very good, sharp eagle eyes. Yes and no. So Neo4j also comes with a new product called Bloom. So this is Bloom, right? In Bloom, we can structure the search query, and behind that, we'll run the actual Neo4j syntax. The reason I wanted to show this is because some of the people we approach, would worry about the learning curve. If we adopt your system, I don't have time to study. So what we wanted to show was you actually don't need to study anything. You just actually have to provide the data. We'll set it up, and you can enter your query in English language.
That's amazing. I mean,
How
I think
cool is that, right?
Yeah, that should really be the trend now. I know a lot of people enjoy learning, the Python and the R and of course the SQL. But not everyone is a data scientist or a data analyst.
And what we're trying to show here is you don't have to be a data scientist or a data analyst. You know English, we'll set it up for you. If you want it in Bisaya, I can set it up in Bisaya if it makes it easier.
That's
right?
amazing. That's amazing.
Okay.
So it's like a contextual tool, no? But does it require a lot of setup initially, or just parang a list of questions that map to a query? So how would, or are you going to show that later? I don't know.
Maybe we don't have time, but we can point them to the right direction. What we used here was Neo4j Bloom.
Okay,
So,
got it.
just use Bloom, and, it's wizard driven naman din, right?
Yeah, amazing.
Okay. So here we visualize the cluster. So each of those red circle represents a positive case. So the first 4-digit represents their Louvain scores. So Louvain score, as you know, in network graph, is a method of determining community. So you can see here that case 15 and case 25 both belong to the same community by reason of having same path as by reason of having interactions, close interactions among the group, right? So it's not perfect, because like you see here, there's 2171, which is another community, case 17, but
Majority of them are
1282s, right?
Yeah, that's
so
good.
what we'll do in the next slide is to shrink this so that you can see the bigger picture. So
Nice.
this is the total number of cases, about 91 cases. And this is the zoom up. This is the portion that we zoomed into, right?
Yeah.
So you will see that, okay, this is one community. This is one community. This is one community. This is a smaller community.
The edges here. What are the kinds of relationships that are used to link them together? Just for example.
Okay, so let's go back to the zoom in view. So you can probably see here the black lines show that they work in the same area. So imagine a large factory with different processes, and each processes have sub-processes, and so it makes sense if you think about it. If you spend like 8 hours of the day together in the same area,
there's a high chance of transmission.
Correct. The others, like the ones in green, they shared a meal together. The ones in green they shared a shuttle ride together.
Right.
And then you can see some here in orange, they shared a meal together.
I think this is very powerful, and something that at least people who are seeing networks for the first time need to appreciate, that an edge can just be a concept, no? Like, we work together, that's an edge. Or
we stayed in the same tambayan together.
Or we stayed together, that's an edge. So it doesn't even need to be a transaction. Because I think there's a lot of people who might think now, okay, there's an edge between us. Was there a transaction between us? Did I
this company even tracked the toilets that you go to.
Right, and if you share the same toilet, you have an edge.
Correct. Yeah.
Okay,
if you share the same toilet within 15-minute interval,
you have an edge. Okay.
You have an edge, right? So, if these guys belong to the same community, then it stands that they would be sharing meals together. They'd go to the same places together. They work in the same places. So, the system computed it from among 10,000 people. They said, okay, these are how all the positive cases are related to each other, right? So visually, okay, this is nice to do, but what's the actionable insight? So here we're going to the actionable insight. Remember the first slide I showed you of all the cases, right? All the cases then were all black because we did not color them by the Louvain community score. Now it's the same graph, but we then put in color coding so that you see case 23 in green shares the same community as case 21 and case number 6.
Right. So the colors show which
that they belong to the same group.
Yeah, which network cluster they belong to. Okay.
So if you think geographically, maybe they belong to the same household, or they belong to the same barangay. No? Something like that, okay? But then that still is a bit hard for executives to understand, right? So this is what I did. Same chart, but I spread out all the community. I spread them out so that all the communities belong to one row.
Are lined up together, right?
They're lined up together.
Is this visualization also on Neo4j? You can do this.
No.
This is Tableau.
Tableau. So
Okay,
I exported. So the nice thing about Neo4j is you can export it as CSV. And then from CSV, you can grab them and then visualize them on Tableau. Right? So here's the thing. You remember the famous 1282 community.
That's all of them.
This is all of them. And so you can see that for this community, ang patient zero nila, 23.
Right.
Now, makikita mo, because of the case numbering, you know that they identified case number 6 first before case 23.
Yeah.
So it means that case 23 was under the radar for a long time.
Yeah. And that happens in reality.
Yeah.
Yeah.
And this was the guy that was spreading everything.
Yeah. So C23 was identified after 6.
After 6 and after 21. So sequentially numbered as. Remember, the case numbers are numbered according to when they were
the sequence, right?
discovered, right?
And then the dates. Is this the onset of the symptoms or no?
Correct.
Okay.
So these are the result of interviews conducted by the client. You know, when did you first experience some of the symptoms?
Right.
And then you work backwards, and you can say, okay, this is the first guy.
Okay.
But the nice thing about here is, you know, that whatever policies were instituted by this company, or if you treat this as a microcosm of a small community, you know that the policies are becoming effective, because you can see that the spread of the
it's getting
the spacing
apart, right?
of the next generation are going farther and farther apart.
And you can benchmark the communities as well. Like you see, this 2171 seems to have had a worse epidemic, no? Because all of the cases are beside each other.
Exactly.
Yeah.
So it's now easier for executives to visualize. Okay, and because most of them works in the same area, you now know which area is hit harder.
Badly hit, right?
Badly hit. And you can also see very clearly which are the community cases. These are cases that were not from the factory. These were imported cases from the community.
From somewhere else, yeah. Exactly.
From outside, from where they're living.
Yeah.
From their barangay, they got infected when they went to the market or something. And they were the ones that brought it in.
Right.
Right. So that's one. So another take-home point of this chart is that, there's a high correlation among the community, right?
Yeah.
Okay.
Yeah, I mean, you have generally 3 big ones, no? See, 1282, 2171, and then there was the 6033, no?
So easy. You can, at a glance, you can now see the largest your top 3 communities.
Yeah, and then that's where you funnel your priorities.
Your attention,
no?
your disinfection. Or if you needed to, if these people represent a large percentage of the total workforce for that area, for that community, then probably your response would be different, right?
Yeah. No, this is amazing. I think this is the intelligence we need to be deploying at scale, no? Anyway, yeah. Show us more. I'm sure you have more stuff to show.
Yes. So now, remember how they wanted to have a testing strategy that makes sense? Have you heard of pool testing?
Yes, yeah.
So pool testing, essentially, you use one test kit for 10 people or 5 people, or whatever your number is. So mathematicians will come up and tell you the optimal number.
Yeah.
Okay. So pool testing will take the swabs of 10 people and then put them together in one test kit. So the idea here is you're expecting them all to be COVID-free. So the test would come out negative, right? But when you get to this guy, the test for these people in this column with the red guy who is positive, means that you will have to use 10 more test kits to figure out who among this pooled test is
Was
actually
was the culprit,
positive.
no?
Yeah. So,
Okay.
so given one positive case among 100, instead of using 100 RT-PCR tests, you are now using only 20 tests.
Yep.
O, tipid ka na,
Yeah.
right? However, if the community suffers from a higher infection rate, let's say 6%, and they're randomly distributed, you will see that your savings from number of tests goes radically down the drain. So from
Yeah.
20, if your infection rate is 6%, then the total test might be 60. You might
Yeah.
need to spend 60. So not a lot of savings. But then, wait, there's more. What if instead of randomizing the pool testing, you
We wait.
actually order them by their community scores?
Yeah, we weight it based on the output of the network, no? Yeah.
Right. So in essence, all these people, you don't know they're positive, but because they belong to
Same
this 1,
community.
2, and 3, because they belong to this community of this row, you decide to put them in along this same row column. Correct? Similar to these two people also, right? So I'm not assuming that we're 100% correct. So here I'm assuming there's one or few that are not.
But you're in a way stacking the odds, no, towards proper
Yes,
detection, no? And I think that's the essence of analytics. You're really,
exactly.
using
Exactly.
data to improve your possibility of accuracy, no?
So how much because we use data analytics, even at 6% infection rate, the total number of tests you now need to pay for is now 30.
Which is less than the 60,
Which is less
definitely.
than the 60. So 30 times, let's say 5,000 pesos,
Yeah,
that's already how much?
yeah,
150,000 pesos.
yeah, exactly.
And remember, you don't do the test only once. You may have to do it on a regular basis.
Yeah.
Yeah, so that's one idea.
And I think this is for me the educated guess. No, I think it's the better way, because if you I don't know if you still listen to the news, no, but I think in the news it's so binary. It's mass testing or just test sparingly, and both of them are not viable. Syempre, if you do mass testing, the impression is it's everyone.
Uh-huh.
And maybe the intention is to catch the asymptomatics, but that's obviously not really viable from a cost standpoint. But if you use data,
Mm-hmm.
then there's I think, a third alternative where you widen the probability of success, but you're not reactive. You're actually more proactive, which is, I think,
Proactive, yes,
a
because
better
now
way.
you can say that, okay, we don't really need to waste 100 tests
Yeah,
now for 100 people. We can actually use fewer tests.
yeah, yeah,
Okay, so now we go to machine learning,
yeah,
which is our traditional. So what we did was we piped in all the usual feature set variables or fields like uh, cough, shortness of breathing, myalgia, anosmia, all the symptoms, age, where they live, and all the stuff. But in addition, we piped in the degree centrality, betweenness, and Louvain scores as part of a. So you can imagine your Excel spreadsheet, but you have extra columns, no, for each
the network data, no, the
the
network
network
metrics.
data. So you can say that this person belongs to this community because of this Louvain score. And and so what happens was we compared it with several algorithms, right? Most of them, the higher ones, are deep learning, decision tree, random forest, and gradient boosted trees. Classification error for naive Bayes is very high. So no, we don't use that. Here, the four ones on the right have better classification errors, right? Now, if we rank, like we looked at random forest, the column weights, look at the number one weight. It's the Louvain.
It's the community, no?
It's the
detection.
community, and I just stumbled into this, and so I wanted to share this with the data science community. Spread natin ito, parts. This is not well known.
Yeah, exactly.
This is not
Because
well known.
all of these other metrics, these are the parang the symptoms, no? And lumalabas, it's really, or the relationships rather, but it's
Yeah.
the community detection that adds the most information.
That adds context to the machine learning
Yeah.
algorithm, so they can make better prediction.
Yeah.
Yeah. Okay. So now here's the other problem: sparse data. You know what sparse data is? Like in this company, they ask people to keep on scanning the QR codes, but sometimes people forget, or
So there are gaps in the
there are
data set.
gaps. There are gaps in the data set. So how do you work around that? Two ways. The scientific way, or the network graph way, would be to compute the Jacquard similarity. Who else in this community or in this group looks like the positive case and the exposed cases? So here you can see that the positive cases are colored red, the exposed cases are colored pink. But for some reason, you have two employees that were not tagged as exposed. But using Jacquard similarity, it shows us that these two people belongs together or share a similar profile to these other people. So it raises the presumption that, could it be that they were not tagged as exposed because they failed to clock in at that time,
On
right?
that time, but
On that time,
they are just as susceptible, no, because of the
correct.
community.
So this is another way to look at the data, right? And then the other way, which is non-data science, is to use gamification. So every scan that you make becomes a lottery ticket. So the more scans you do, the higher your chances of winning something.
So that's more about incentivization of the process, no, to
Yes.
get them to ano. Yeah.
Yeah. So here's the technical. Here's how we did it. So very simple steps. You ingest the data sets. You pre-process the links. Because remember, later I will explain. You compute the network metrics. You then label people as either positive or exposed. You compute the Louvain and the Jacquard. And then you extract CSV and visualize it in another program or software, right? So, okay, step number one, ingest the check-in data. So this is how it looks like in Neo4j. You load the CSV with headers from your file location, and you put them in a variable called CSV row, right? And then you merge. The key here is to use merge and not create, so that you don't have duplicate employee names. So the merge keyword says, if this employee number already exists, do not create it anymore.
So it's a way of deduplicating it when you create
Correct.
the table. Okay, that's good.
So if it doesn't exist, then create the employee number from CSV, which is the variable .employee, which is the field in that table. Next, we also merge the location because this is the check-in data. So a person with an employee ID check into a location. So this is the location name, right? So again, we use the merge command so that the person can, the data schema can create a location if it doesn't exist before, right? So this is just in dealing with the creation of the nodes. Now here is where we create the relationship. Here we say create the employee was at whatever, and then all these are the data, whatever table name or seat name, it's embedded as properties in the link itself, right? And so it's just a declarative, this person was at this table on this day and time to this place.
Is this script the kind of script that can also be kind of abstracted using Bloom, so you can have an English version of it, or is this more of the prep, parang data prep, no?
This is data prep na lang. Anyway, you can just cut and paste.
Yeah.
Everybody knows cut and paste. So Once the data, the codes are there, madali lang siya.
Okay.
So that command would have created a node for an employee with a link that says he was at a canteen. If you were to highlight this, you can see that this is the ID of the link, date, hour of the day, which is 18, which is 6 o'clock, and minutes of the hour, which is 11. So 6:11. He was seated in seat number 1 in table number 1. So the data is embedded in this link. And then here's this another person that was here in the canteen, same table, I think, no? Same table, different seat ID. So what we did here was we then created bipartite links to tell Neo4j that these two people are near each other or have a relationship to each other.
And that
right?
creates another edge between them,
Yes,
no?
two edge between them. So it's bipartite so that when we query, it can go either way. And so here's the code. So we match all the employee that was at this location during this day. So because of the sheer volume of the data, I found that I needed to set date parameters so I don't process everything. Otherwise, it will take me 2 days to process everything. It's better to process in batches. So here is the added code. And here is the filter that says, only create the bipartite links when the time difference between the two people's check-in is below 15 minutes. Okay. Now, if they were, then you create a link from this guy to this other guy and then embed the table ID and seat ID and day and all the other details. Pretty simple. Now, next, they also had daily health declaration where an employee is supposed to tick off, are you feeling well today? If you say yes, then that's it. If you say yes, then that's it. If you say no, then there's a series of questions, what are you suffering from? Breathing difficulties, a chill, sore throat. So in this case, we see that this person did suffer from chills. So every line means that that's a single day. So this guy has been suffering from chills for 4 days, and yet he was still going to work.
Wow. And was it, of course, do you detect this after the fact, no? Maganda if...
We were called in after this happened.
Yeah.
But then
this is obviously an issue that you can highlight that, people were noticeably spreading the symptoms, no?
And so this was a parang key visual, because if you were the chief executive and you knew that people were sick and were still working, then you have to ask yourself, why? Shouldn't they be at home so that the disease doesn't spread further? And so this started off a chain of conversation that then led to changes in HR policy. So you see how powerful.
Yeah, the symptoms are the actionable parang levers, no?
Correct.
Because now you can see that, okay, one of the nodes had all 4 symptoms. And then the
cough,
other
sore
3
throat,
had,
breathing difficulty, and chills.
And then,
this guy, why are you still there?
Why are you at work?
Why are you at work? And so that spun off a whole set of conversation. And, they did very fantastic HR changes. And that contributed to encouraging people to stay at home. And that was one of the key pillars of stopping the spread. So this is how you ingest the self-declaration data. So after you load the file, you then see if you need to create a new employee. And then for each link, remember there are several symptoms. So we use a for each clause that, if your symptom is fever, then you say we create suffering from this one where your symptom is fever. This is the S1, right? If you're suffering from cough, you set S1 to cough, and then you create that cough. Because the way the data came in, it was a lot of yes, no, yes, no, yes, no. So you have to test each one. And, I figured if the guy isn't suffering from cough, why create a link? you know, you're just unduly creating so much relationships, right? So we only created relationship when there's a yes answer. So now here is the actual Neo4j command, you know, display shortest path between two employees, right? So the program will go in and find, you know, how are these two exposed individuals related? And you find that, oh, they're related because this guy shared a meal with this guy who then shared a ride, 2 rides, 2 days with this other infected person. So could it be that this guy passed it on to this guy who then passed it on to this guy? And therefore, you now find the hidden node.
Yeah, exactly. And then that's how you find the silent spreaders, no?
Exactly.
Which is really the problem that every country has. You don't know who are spreading it, you know, silent spreaders.
Now, because you see, this guy has no direct interaction with this guy, you then think of how did this guy infect this guy? But then using Neo4j's shortest path algorithm, it will pop it up. Yeah. So ingest and tag positive. So one of the other data that is sent to us is the list of employee numbers that then prove to be positive. So the way we set it is we set a label. This one. Sorry. We just set for every match where the employee code matches, you know, you set that employee's label with an additional positive case label. That's it. And then you may probably also add some details to the employee, like, you know, what case number, when was the onset, when was the infectious start and end date, you know, were they tested, and so on and so forth. But the key here is to just label it. This employee is now labeled as a positive case. So here, we'd like to find the link between a positive case and employees that falls within the infectious window. So this is the positive case. And you will see that the program correctly tagged this guy as being exposed, but not this guy. Notice it's color-coded, so it's easy to see.
You know how to classify them, no?
Yeah, okay. So here's the detail. Case 81, the date is this one. The infectiousness this case 81 started to be infectious on July 9. And the end of the infectiousness period is July 27. So it's calculated. Now, this guy over here had a shared ride with this guy on where is it? Here, July 9, seat number 19, where the other guy, this guy, is seat number 2. Right? Now, why was this blue guy not included? Oh, because he had worked in the same area or shared the ride 2 days before he became infectious.
And that's where the person caught it, no?
So this person did not catch it.
Mm.
And so this is correct. We did not tag this as an exposed person.
As an exposed, yeah.
So how do we tag? So we match a positive case with all the employees that had a relationship or a link between the positive and the employee. But we filter it to only when the interaction date was between the infectiousness start and infectiousness end. Makes sense, right? Very easy. And so if it matches, you just set the employee as exposed. Remember, we are not saying he's positive. We're saying he's exposed. And then we add in all the other data. So this is the schema. Notice that for this company, their data also includes rest area, tambayan, CR, locker, dressing room. We know the work shift, leaves also. We also track the leaves. So if a person is having symptoms and they applied for leave, we can tag it as something that needs to be investigated. And then now we go to the supposedly hard part. You know, Louvain scores and Jacquard similarity. They sound intimidating, but it's actually very easy to generate. So inside Neo4j is what we call the Graph Data Science Playground. You just install it and you select centrality, select, and then you select degree centrality or betweenness, and it will compute the score and append it to the record of the employee. That's simple. For community detection, that's what we use for Louvain. For similarity, this is where we went to. That's simple.
That's it, no? Imagine
And
that, no?
yeah, and this is how it looks like. This is how it looks like. Remember, Neo4j can display the output as a table or as a text in addition to displaying it as a graph. So this is the employee number. This is the degree centrality that was computed and stored as part of the employee number. Betweenness score, Louvain Community 2171. His labeled is employee. So this guy is not exposed or positive. And then if you click on this area, you can export it as CSV. Now, there's a new play toy that comes with Neo4j. It's called Neo Map. Given your underlying data, you can even visualize it in a heat map a la Python's volume. And with that, we end our presentation.
That's fantastic, no? I think...
What do you think?
No, I know you've been talking about this concept in previous fora, no? And I'm just wondering, it's the same thing that I mentioned before we started the talk. No? The technology is out there, the data is out there, the knowledge is out there, and obviously, thanks to you, we can now evangelize more people to do this. It's just amazing that the adoption isn't there, no? And I think that's also worth thinking about, no? And because I've been also working with, you deal with PSPHP. I also deal with them, and they're in the similar boat, no? They're trying to convert local governments to adopt data-driven methods. And the thing I like about PSPHP is they were quite open about needing more collaboration between the public health and medical sector and data science. It's amazing that, you know, I found that surprising that until now, people haven't really collaborated enough.
And Doc, coming from you, another pillar in the data community, data analytics community, that means a lot.
Yeah.
And, you know, if you help spread this, you know, our goal is really, when we went into this, our goal is to help stop, because we have businesses in the Philippines and we are all suffering.
Yeah.
We are all suffering, and, you know, we've been sharing this with the IATF ever since April, you know. April, May, June, July, August, September.
Yeah, and well, I don't know how Singapore is doing, but for example, the Philippines has had one of the longest, if not the longest, lockdowns, no, in various degrees. And
How is Singapore doing? Well, there are days last week, 2 days straight of zero community spread.
oh yeah,
That's
good.
how well Singapore is doing it. And I tell you, you know, they're doing digital contact tracing.
Yeah.
Everywhere you go, you have to wear your mask, social distancing, and you have to check in, check out.
I think that's also another leg that needs attention. Kasi for obviously, you've got the algorithms, you've got the graph modeling,
The data.
but the data gathering is the big block, though. And I don't know if I'm unfairly generalizing, but I mean, I'll cite myself as an example. If I walk into a Starbucks, the last thing I want to do is fill up a small slip of paper. That's how we do it here. No?
Yeah.
And
you know, the famous Optimus Prime example. Have you seen that?
no.
Who are you, Optimus Prime? Where do you live? Planet Cybertron.
Somebody did that.
They think they're smart. They think they're smart. But what if that place was also visited by a positive individual?
Yeah.
And they had to contact you to tell you to take precaution. You think you're smart? Now they can't contact you. So you never know that you have been exposed. And so if you were carrying the virus and then you now spread it to your parents, your grandparents, that's on you.
Yeah. Yeah.
That's on you. You think you're smart, huh?
I think there's a social responsibility. I mean,
Exactly.
Since we're talking about the ethics, on the one hand, the ethical question is the data privacy. But on the other hand, we also talk about social responsibility as a part of ethics. And there's nothing in life that doesn't have risks. So you then weigh the risks, right? The risk to yourself, the risk to society. And I think, and of course, maybe the jury isn't out on this, but over time, people should realize that the small risk to your privacy, in so far as it can be quantified, is outweighed by the benefit to
To the
society.
community.
Yeah, exactly. And I think it's incumbent. It should be. Let's say if we can prove the point that this thing really works, like those percentages are amazing. No?
Wait. This thing really works. It's not a proof of concept.
It's an actual implementation.
It's been
Yeah.
applied. So all those data, those were actual data.
Yeah.
And all I can say is, look at your community. The cases are still going up. And yet, that factory inside that community where the cases were going up, they were flattening their curve.
Had
And these are
flattened already.
10,000 people working alongside each other, 8-hour, 10-hour shifts. If it can be done in that factory, why can't it be done elsewhere?
In a broader context, no? I think even the term community, people mistakenly assume na it has to be like an LGU or a barangay. It can be as simple as your office building, for example, or your factory or
Your condo.
your condominium. It's a very portable concept. If you have the good data gathering, you've got the network analysis, and then there's the prescriptive approach where you actually then identify potential likely carriers.
We can predict.
Yeah.
We can predict ahead of time. Now, here's an idea also. If you extend the QR code check-in, check-out system to public transportation,
Yeah.
right?
That's it. That's the
That's
data.
it.
Yeah.
That's it. You
Yeah.
can now offer public transportation to all those people along EDSA, lined up along EDSA every day.
Yeah.
In Singapore, we don't actually have social distancing anymore in the MRT. We can sit side by side together.
So they've already gone past all these cosmetic,
There's a loosening.
initiatives. Yeah.
There's a loosening because initially there was spacing required, no? But if you have face mask and you observe, you don't talk. Very important, you don't talk. So you don't spread germs. And then, contact tracing, QR codes, scanning. That's the solution to public transportation.
And I think it's better than waiting for a vaccine to come out of nowhere, right?
The vaccine will still be a year from now. So
and that's a best case scenario. I mean, that has to be tested, clinical trials. I think people underestimate the need for trials because any new vaccine can have new side effects, and
especially in the Philippines with the recent Dembaxia.
The stigma of it as well. And
I don't know how many people will line up to get it first.
Yeah, for sure.
Yeah. All we're saying, we in the data science and analytics community, we know the value that the data that people or LGUs or businesses are collecting, if they apply network graphs theory to it, it can help them tremendously. But, sadly, everywhere we go, it's like, kaya na namin to using our old analog system. Kaya na namin. Kaya mo na kung 1 or 2 cases. Wait till it gets to 1,000. Can you contact trace 37,000 people?
They say kaya nila from a compliance standpoint, like the DOH will require a report. They can produce a report, but does it mean that it actually works?
I heard that LGU contact tracing, when somebody gets positive, ang kino-contact trace lang nila, sino yung kasama mo sa household.
Right.
Hindi na tinatanong, what other places did you go to? Where are you working? How did you get to work? Did you go to church? So and we wonder why we are not flattening the curve.
Yeah.
Kulang ang contact tracing.
And I think when people already are so numb listening to terms like contact tracing and testing, without realizing what it really meant. And I think one thing that we can get out of this, what you shared, is this is the concrete outcome. No, when you say contact tracing, this is really what's involved. We're really building network data sets. And what's the value of doing network data sets? Accuracy and predictability, and you can isolate rather than doing like a shotgun, one size fits all quarantine. And it's obviously I don't know how the economy of Singapore has done, but it's definitely wrecked the Philippine economy. We've seen 70-60% declines in certain sectors. So the cost is really that's the price you pay for being inaccurate, the economic decline, no, rather than being targeted about the solution. But then that means you have the data to target with. And
two things people can talk about, think about, especially the political class. Among a sea of old politicos, if you are the only politico, like let's say Mayor Benjamin Magalong that applied digital contact tracing methods, sino sikat? Siya ang sikat. That's one thing. So if you want to win in the next election, I think how you protect your community from COVID is going to be a big factor. First thing. The second thing, let's say your community is the only community within a radius of 500 kilometers that have zero COVID infections for 90 days. You know what happens? Businesses will relocate to your place.
yeah,
Right? That's what we call a COVID dividend.
yeah,
And now mayors are actually scratching their head, no business. Where are we going to get local taxes? Fix the COVID and business will come back to you.
yeah.
Does that make sense?
Yeah, absolutely. Yeah. And that's a governance implication as well. Like, because everyone's used to firefighting, and this is actually getting ahead of the fire and then bringing the value back to the community.
Yeah. But then you see, only few places or few municipalities or cities in the Philippines have actually mandated QR code access system when you go into establishments.
Yeah.
That's crazy. You can spend how many billions to do other stuff while this one just calls you a mandate.
Yeah.
You just mandate it, legislation, i-mandate mo lang. Hindi mo magawa.
Yeah. I think the confidence of let's say I'm an LGU official, I'm the mayor, I'm the governor. Confidence builds when your results come in and you break that ice and you show that, hey, look, this has worked in a small context. Let's give it a shot. I'm sure there will be a few people who will want to test it out.
Meron.
Yeah.
So
Then you prove, parang diffusion of innovation yan, if I remember from someone's talk. There will always be an early adopter, and then the rest are the laggards. No, you get them after the early adopters.
Yes, and word goes around. With the successes in the engagements that we've done for several companies, large companies, word gets around, and there are a lot of big companies that need the same help. Yeah. So just, our message to the LGUs, just mandate QR-based contact tracing.
Yeah. Let's talk. It's been an hour na, ang bilis, no?
Bilis,
Yeah. More about the community naman, the data science community.
Okay.
Obviously, you studied network analysis. That's a great book you provided, and
it's free for the next 15 days.
Yeah,
Download it, guys.
And then you got certified in Neo4j, tama ba?
Correct.
Neo4j,
Just took me 3 days. Go over the exercises. It's very easy to learn the pattern. It's a pattern-based language.
Correct. So I was gonna ask you, coming from someone who has also dabbled with other parts of data analysis, no, what do you find? What about network analysis that you really find interesting, no, and how it complements other disciplines that you've been playing with?
It really mimics the disease spreads through social contact. Neo4j grabs the social fabric of the society.
Yeah.
What more perfect tool do you need for this one?
Yeah. And it's still a database, right? Neo4j is still a database, no? It's a
Some
graph,
sort of a database, yeah.
graph database lang nga.
Graph database. And there are a lot of people that are better than me at Neo4j, but I believe that if we spread this and a lot of people start learning and we start helping each other out, we can accelerate the learning for Neo4j, because for sure, once all of the municipalities come to us and say, Wilson, can you help us? I can tell you, I don't have the bandwidth anymore. Right?
to attend to all of them. No? Yeah, that's amazing. Yeah, I remember we also used network analysis when we did the disinformation, the fake news detection.
Exactly. So it's very versatile.
You can apply it to any other domain, no? It's really about the data, understanding the relationships. I think that's the secret sauce. Once you have the machine, it's how you feed the data into the machine, and then all the patterns just pop up immediately.
And this might not be a well-known fact. Neo4j has a community edition that's free to use.
For everyone, no? Yeah.
For everyone. And they even have the sandbox, I think it's called Aura, that's free for use for 3 days online.
Is that on the cloud? You can play
on
with
the
Neo4j
cloud, yeah.
on the cloud.
You it's a sandbox. You play with it on the cloud, but the data goes away in 3 days.
Yeah.
So if you don't even have money for
the license,
for the license
you can
or
play with
machine,
it.
you can just upload it. So you just need good internet.
Yeah, the which obviously you've got in Singapore. Yeah.
In spades. I have a gigabit of fiber here.
Yeah. No, but I still think even if people give, let's say, the community edition a shot, it's really amazing that drilling back to and I think network analysis is not new. It's not a new thing. It's classical mathematics, no. But I think it's only recently that the tools have been available that allow you to do it. Before it was so painful to do. You have to really create the graphs manually. It's hard. Yeah.
I like your background. Is that your true office or is that a
No,
virtual background?
it's fake. There's actually a jacket here. It would just appear. No? Yeah. Yeah.
So what do you think? Would you recommend to LGUs, use Neo4j with your data and see what sort of surprise insights you can get?
I think, well, just to share, dealing with the LGUs, they're really game for anything, right? To the extent that they have the budget for it. And even if they don't have the budget, another thing that, and I'm happy to share, is there's actually a lot of funders just waiting to throw money at something. But it has to be concrete. And I think having a network analysis as part of your solution, that makes it concrete, because everyone can appreciate what a network looks like. Okay, this is community 1, community 2, community 3, and this is when the infection happened. It's really much more intuitive than looking at, the usual graphs and charts. And I think everyone's already sick and tired of watching case counts and, the R naught or the RT going up and down. You still need those, but it's hardly actionable. It's really like RT is good as a confirmatory score, no? Okay.
So what do you do with that?
RT went down, then I know it went down. But what do you do?
It's a lagging indicator. It tells you what happened in the past.
It's like the stock exchange index, no? When it went down, tapos na yung laban, no? And
tapos na.
Or the GDP, and so here you're giving someone an actionable indicator that can get ahead of the phenomena, no? Like before someone probably gets sick, or at an early stage, you're able to arrest the infection,
quarantine them so they don't spread it to other people.
And I found that slide, the one with the symptoms. I think that's also a game changer, because you're also tracking not just the people and the relationships, but the possible vectors, no, that you can control, no.
Hindi pa sila nagpapatest, alam mo na suspect ito.
Kasi
kaya huwag ka na munang pumasok?
Yeah, they share the same profile, no? And actually, yun na nga, I don't know if it was you or someone, graph analysis actually first became famous in Scotland Yard yata or somewhere where they used it to track criminals, no, based on their modus operandi, like serial killers. So it's actually a forensic tool, and what you're doing here is forensics for public health, no, and that's really what's sorely needed now, no.
Another insight that I failed to discuss when I showed you the A, the B, the C.
Yeah.
When the vaccine becomes available, it will not become available in massive quantities.
Yeah. So you can choose where to apply the vaccine now, no. Yeah.
And looking at the graph of a community, you will now know who to prioritize.
Yeah. Yeah.
Who would you prioritize?
Yeah, you have to deal with the spreaders and those bridge nodes, no? Kasi they're the ones who could link communities with each other, no?
Exactly. So given limited resources, you can maximize the impact because of data analytics.
Yeah. Yun nga ang ano nila eh, parang everyone's hoping for either the vaccine to appear or what they're calling herd immunity, no? Herd immunity. And actually, the network gives you how herd immunity can work, but for us to experiment with herd immunity is suicide. That means we're just gonna let people get sick. Yeah. But when a vaccine occurs, you can now select which nodes to. In a way, you're deactivating the nodes so that they no longer spread the virus. And again, the disease is still, from what I'm seeing, the disease is still evolving.
It's still spreading.
Yeah, and I don't know if you caught this, but the CDC did the flip-flop the other day. Parang,
aerosol?
Yeah, aerosol, and then suddenly nawala, no? Suddenly it's no longer aerosol again. And obviously there's a political something there. But it's
ano lang daw yun? It was still a draft that wasn't meant to be publicly published.
But
so they had to take it out.
Whether you can't be walking around in denial that this thing can't get to you from the air. I mean, it's just an excuse for people not to comply with.
Now, having said that, this is a novel disease. So every day we learn something new. Yeah. So that's why my ending slide is collaboration welcome. So this is what I've done. I'm sharing it with the community.
Yeah.
Take it with you, run it, and see what other new insights you can generate and share it back to the community. And then let's work together and help, because the Philippines is not the Philippines is not a very rich country. Yep. We cannot afford a very long lockdown.
Yep.
It's our duty. We have a God-given gift for crunching numbers, looking at patterns. Not only you and me, a lot of people in our circle.
This is a public good, and I think this is what we need to promote, that we're doing this for the good of the society, and I think we don't have enough of that. And I'd like to personally thank you, Wilson, for taking this effort. I know you've had similar challenges like this where you're the only sane guy in the asylum, as they say, and you have to convert the converted.
So you just keep on being makulit. We just keep on repeating the message, and sooner or later there will be somebody that will be desperate enough to say, we've tried everything else.
We'll give you a shot.
What else can we do?
Yeah.
Remember, we've applied these concepts in 2 companies already, and in both companies, flat.
It worked. Yeah, exactly. Okay.
What else? What else are they waiting for?
Yep. Okay, so obviously I'd like to talk for another hour or so, but
obviously we could talk the whole night. You and I have a lot of things to exchange.
There will be other topics, but at least on this topic of COVID-19 response and network analysis, I'd like to thank you, Wilson Chua, for sharing your knowledge, and I hope the community will find this useful, and we have more people talking about graph analysis and contact tracing. I don't know, is there a community for this? Because I know we collaborate on the mosquito group, for dengue. I don't know if we should come up with another group for this, or maybe the existing
there are
groups.
A lot of data science communities on Facebook. The ones we run is the Big Data Analytics PH.
Yeah, I think I'm part of that too.
Yeah, just join the discussion.
Yeah.
What else?
And this is obviously going to make the rounds in the data ethics community, because we talked a lot about the ethics and the social responsibility of this.
A lot of your listeners are in the community, data analytics people, and hopefully it will fall on the ears of decision makers, people in DOH, people in IATF, people in World Health.
We're actually getting not a lot, but starting to get people who are actually working in government. In fact, I met PSPHP because of data ethics. We were running another podcast with epidemic modelers, and they were in the audience, and then that's when the relationship started. So as long as we just keep talking about it, I think that's what people will start seeing the light. And I think the generosity of the time and the knowledge is priceless. So thank you for that.
I was also once a beneficiary of somebody that mentored me and tutored me, so we're just
paying it forward,
paying it forward. And if enough of us pay it forward and mentor other people and help them, it's a big force to reckon with.
Critical mass na yan, for sure.
Critical mass na yan. Right now, it's just, what we're doing here is something that bahit namin susubukan yan. Never tried before.
Yeah, but you're proving it already, so.
It's been done.
Yeah, the early adopter is already there. Okay. So thank you very much. I think that was a great session. Thanks again, Wilson Chua, for coming aboard, and we'll hope to see you again in another session, data ethics.
All right.
And everyone keep safe, and till the next podcast.
All right. Thank you. Bye-bye.